Recording in progress.
Okay, so we started chapter 11 and we did 11.1 and 11.2 last 2 days. Last 3 or 2 days. So let's recall what we did because we need the knowledge of first and second one in the other sections too. So I will recall again what we have done so far. So recall 16, I guess it's 14. Yes. Okay, so recall what we did. So we started with a sequence. So we write sequence like this. So sequence means it's a list of numbers. And here this is called the n term. And then if we want to know whether a sequence is divergent, what we did was we showed when n approaches to infinity, a sub n, if we get a finite number, then we say this sequence is convergent. Sequence is convergent. Okay, if we get the limit n approaches to infinity, if we get an infinity or negative infinity or do not exist, we say the sequence is divergent. Is divergent. Okay, so this is sequences. And we did many sequences, increasing sequences, decreasing sequences, monotonic increasing, monotonic decreasing, and showed when a sequence, if a sequence is monotonic, increasing or decreasing, and if the sequence is bounded, then we mentioned that the limit, this is convergent. This sequence convergent. So this is what we did in sequences part. So let's recall what we did yesterday, that is series. So series, what is a series? We write a series, infinite series, as this sum and n equals 1 to n, a sub n. So this is called an infinite series. Also, we can just say series. And then, so we, anyway, in sequences also, at the end of the day, what we want to know, whether it is convergent, not divergent. So here in the series also, we want to know whether it is convergent or divergent. Okay, so in the series, we can also write this by limit when n approaches to infinity, s sub n. So what is s sub n? This is called the partial sum. Partial sum. So what is partial sum? If we write partial sum as sub n, this means you add all the terms in the sequence. So up to a. This is called the partial sum. So infinite series means when n approaches to infinity, we are going to find the value. Like we are going to find the partial sum when n approaches to infinity. That's the infinite series. Okay, now then what do you mean by convergent and divergent in series is, so this is the infinite series. That means limit n approaches to infinity, the partial sum. So if we get this is equal to L, that means it's a finite number. Then we say the series is convergent. And also if this is equal to infinity or negative infinity, then we say the series is divergent. So this whole thing is series. That's the basic idea. So we want to know whether the series is convergent or divergent. And then what we learn? So we learn some types of series. So the first one we said arithmetic series. So arithmetic series means the sum of the partial sum we can get by A1, that is the first term, and the last term divide by 2 and multiply by n. And also we mentioned geometric series. So that is, if you have like this is a geometric series, and the partial sum of a geometric series is I can't remember what is, can you remember what is the geometric series of the partial sum of the geometric series? It's not coming to my mind right now. So it's you will find from the yesterday notes. I gave the partial sum of the geometric series when R is less than 1. Okay. And the other type of series is we learn is harmonic series. And harmonic series is always divergent. Okay, it is always divergent. If you have a harmonic series, this is the harmonic series, 1 over n. So this is always divergent. Okay, and the other type, okay, let's see. Thank you. So it's the sum A1, A minus R. This is the sum of the geometric series. Thank you. Okay, so harmonic, I was in harmonic series. Harmonic series is this type. It is always divergent. Okay, so these are some kind of series, type of series. Okay, then we learn, so because at the end of the day, we need to know whether the series is convergent or divergent. So we learn a method called divergent test. So in this divergent test, what we did, so what is the divergent test? So if you show the limit when n approaches to infinity, an is not equal to 0, okay, so we can say the series is divergent. Okay, if the limit approaches to n approaches to infinity, an is n term is not equal to 0, then the whole series is divergent. And remember very This is very important. If you get n approaches to infinity, a sub n, is it equal to 0? We can't say the convergence or divergence of the series. Okay, so this is what we did yesterday. Okay, so let's start from today's lesson. So today we are going to learn another type of test where we can check whether the series is convergent or divergent. Okay, so today this is 11.3.3 and this is called integral test. Integral test and estimates of sums. Okay, so let's see an example. So this is what we are going to do. So example, series of, now you need to know what is whether this series is convergence or divergence. Okay, so we need to know which type of test that we are going to use. So here we use, a test called integral test. Integral test. Okay, so now let's see what is the integral test. So let's say, let's first write the note and then I will explain. So let's say a sequence can be defined as a function. Of n. Remember, I said always a sub n we can think of as a function. So here that's that idea we are going to use in integral test. So the a sub n, in term of a sequence, I'm going to write this as a function of n. Okay, so that is f at n. Okay, so in the n term of a sequence, I'm going to write it as a function of n. This is a function of n. Okay, now I'm going to, next is in order to use integral test. So before using the integral test, we need to satisfy some conditions. If these conditions are satisfied only, we can use the integral test. So let's see what are these conditions. So the first condition is we need to check the function f must be, so the first one is it should be positive. So the function must be positive. Okay. And the second one, it should be a continuous function. There should not be any holes or discontinuities. You cannot be, it should be continuous. The third criteria is the function should be decreasing. Okay, so so these three conditions should be satisfied. So these should be satisfied in when x is greater than equal to 1. So that means x should be in the interval of 1 to infinity. You will understand when we're doing an example, but just for sake of note, these three conditions should be satisfied in this interval, 1 to infinity. Okay, because we are writing this function. So because we are writing the f at n, we are writing this is at f at x. Instead of n, we are writing x, function x. So fx should be positive, continuous, decreasing, and it should be, all these three criteria should be satisfied in this interval, 1 to infinity. Okay, so then if these three conditions are satisfied, we can use integral test. Okay, now let's see what is integral test. So basic idea of integral test is so we are taking the integral 1 to infinity f of dx. So when we find this integral, if we get a number that is n, it's a finite number, so this means then the integral converges. So if we find the integral and you will get a finite number, then we can say the integral converges. If the integral converges, then we can say the series converges. So this means our series converges. Okay, so the idea is we have a series. Now we need to check whether this series is convergent or divergent. So we are applying the integral test. Okay, so when we apply the integral test as the integral, if we get a finite number, we say the integral is convergent, and then we can say the series convergent. Okay, that's the idea. So if the integral dx, if it is infinity or negative infinity, then we say integral diverges. So if the integral diverges, then we can say the series diverges. So in the divergent test, we can only say about the divergence of a series. Okay, but in integral test, we can say both. So if we get the integral if we get a finite number, we can say the series converges. And if we get the integral as infinity or negative infinity, we can say the series is divergent. So we can say both in this test. Okay, so now let's move on to our example again. So our example was to check whether this series is convergence or divergence. Okay, so let's see whether this is divergent. So we are going to use the integral test to solve it. But before using the integral test, we need to satisfy three conditions. So let's see. Let's first write. So the first step, whenever you have a question like this, the first step is write the corresponding function. That is fx. So your corresponding function is 1 over x plus 2 square. Now we need to check whether this is positive or whether it is continuous, decreasing. We need to check all these in x is between 1 to infinity. Okay, so let's check whether this is positive. Okay, so let's check whether this is positive. What do you think? Do you think this is positive or not? What do you think? Is this a positive function or not? Squared. Yes, yes. Some says yes. What about others? What do you think? Yes? Yes. Yes. So this is positive in most of for x values. So this is because of the square, because of this, I saw correct answer. So because of this square, you will get always positive values, but except in what point? Except in what point? X is equal to -2. Okay. So except when x is equal to -2, because x plus 2 is a square, your function is always a positive function. What happened at x equal to -2? At x is equal to -2, the denominator becomes 0. Okay, so then your whole function will be undefined, right? Not continuous. So it's not continuous. We have we will get a vertical asymptote. But most of the part it is positive. Okay, but I will let you know why we are not taking this one in the other steps. But we found that it is positive. Okay. Okay, now let's check whether it is continuous. Is it continuous? Is it continuous? What do you think? Is it continuous? Okay. So what do you think? Is it continuous? Yes, because x is, yeah, it says yes. Good, Kyler. Okay, so so if we consider the whole function, this is not continuous because we have x is equal to -2, we have a vertical asymptote. Okay. So at this point, we have a discontinuity. Okay, we have discontinuity. So it's not continuous everywhere. It's not continuous everywhere. But remember, yes, very good, Kyla. But remember, I think it was Kyla. But remember, we had the conditions. We said that this is true. We can, if these conditions are satisfied when x is equal, greater than or equal to 1. Remember this condition? So x should be between 1 to infinity. Okay. So we found at x is equal to -2, it is discontinuous. But is x is equal to negative is inside this interval? No, right? Because -2 is not in this interval. So we can say, because this is not in the only the function is discontinuity, we can find a discontinuity is only at this point. Okay, but we are taking all the x terms greater than equal to 1. Okay, so that means that doesn't matter. This doesn't matter for our question. Okay, so we can say continuous. The function is f is continuous in 1 to infinity. So that condition is also satisfied. So we have positive, we have continuous. Okay, then we have to check whether this is decreasing. How do we find decreasing? We can use the first derivative test. Okay, because we are considering functions, we can use the first derivative test. So what is first derivative test? If we take the first derivative of the function, and this is less than 0, that means if you get a negative value, negative, then we can say f is a decreasing function. Okay, so now we need to check whether this function, our example, our function is decreasing. So what is fx? We have fx as 1 over x plus 2 square. Okay, now can you tell me what is the first derivative of this? Can you all find the first derivative of f? Uh, we have an answer. Okay. But let's wait for others too. What is the derivative? Okay, yes. Okay, so let's say, I see many correct answers. So we can write this as same as x plus 2 to the power negative 2. Okay, and then we can use the, we can take the first derivative. So this is negative 2 x plus 2 negative 2 minus 1, that is negative 1. So negative 2x plus 2 to the power 3. Okay, okay. So is this is negative or positive? It's negative. Okay, but remember we need to check, we have to check the sign test. Okay, at x is equal to negative 2, the numerator denominator becomes 0. So we have to check beyond negative 2 and less than negative 2. So if we take less than negative 2, is it positive or negative? The first derivative, positive or negative? It's positive, right? We can use, like, let's say x is equal to negative any number, like negative 3 or any number, and then we can check the, just substitute for here. Let's say if x is equal to negative 3, your denominator, so your numerator is anyways, it's negative because it's negative 2. But denominator, you will get a negative value. So it's positive. Okay, it's positive. So then what about when x is equal to, let's say, 0? Then what happened? Is it positive or negative? Your first derivative? Negative, right? Because it's in the denominator is negative. Denominator, you will get positive. So it is negative. Negative divided by positive is negative. Okay, so we have from negative 2 to positive infinity. We have the first derivative is negative. So f is decreasing. But we need, so if we draw the real line here, so here this is the negative 2. So all these parts, the first derivative is negative. That means f is decreasing. But we need only this part, 1 to infinity. We need only this part. But that is also inside this interval. Okay, so then we can say f is decreasing. Okay, okay, but still we didn't use the integral test. Okay, so we use the condition that we can use the integral test. So here we satisfied f is continuous, f is decreasing, and f is now positive in x between 1 to infinity. Okay, all these conditions are satisfied. Now we can use integral test. Now we can use integral test. So what is integral test? We need to find the integral from 1 to infinity fx dx. So this is the improper integral. So we are going to write this in terms of a limit. When we have done this in the chapter 7. When b goes to infinity, approaches to infinity, we write as a definite integral. Okay. Okay, so now can you find what is this part? So b approaches to infinity, 1 to b, our fx is 1 over x. I'm sorry, x plus 2 square. X plus 2 square dx. Okay, can you all check whether you get a finite number? Can you all switch on your video? You know the system, right? I see some of you doesn't switch on the video. Because I don't know whether you're here or not. So we have Emma says it's convergent. Let's see what do you think? Others? Emily said convergent. Colby said convergent. Mallory said convergent. Lee, Kyra, good. So Riley said convergent. So many of you got it as convergent. So let's check. So let's first find what is the integral of x plus 2 square dx. You can use either uh, u substitution and or any other method. So if you use u substitution, u is equal to x plus 2. Du is just dx. So if we change this is 1 over u squared du. So this means u to the power -2. So you already know these stuff, so I'm not going to explain more. Plus 2. Okay, so this is the definition you get. So let's write from here to here. This is equal to limit when v approaches to infinity to be plus 1 over 3. When you substitute x is equal to 1. So when you take the limit, this is anyway b approaches to infinity. This whole thing becomes 0. So 0 plus 1 over 3. This is 1 over 3. So now this is a finite number. So what we found is, we found 1 to infinity dx is a finite number. This is a finite number. Okay, then we can say our series is convergent. Then our series is convergent. What was our series? Our series was this one and plus 2 square. So this is convergent. Okay, it's fun. So, but I know it's kind of, you have to do much work to use the integral test, but this is, if you like doing, this is fun. So let's do another example. what about this? Can you try to do this one? So now we need to check whether this integral is convergent or not. OD. Okay. So first step is we are going to write the corresponding function, x function. So our f at x function f is 2x over 3x squared plus 4. Okay. Now check whether this is continuous. So can you tell me whether this is continuous? Is it continuous? Is it continuous? Mallory said yes, Colby said yes, Riley said, Riley, I'm sorry, Riley said yes, Alexis says yes. Okay, many of you says yes. So why it is continuous? Yes, Mika said yes. Why this is continuous? We don't see any discontinuities, right? Because in the denominator, if we consider the denominator, this part here, it is a 3x squared. It's always positive one, and we will not get any vertical asymptotes, right? It's always we don't get any holes in the graph, so no points of discontinuities So the function is f is continuous. Okay, now let's check whether this is positive. What do you think? Is it positive or not? Is it a positive function or not? Yes, same reason. Yes, yes. I say Colby says yes, Skylar says yes, Lee says yes, Riley says yes. Yes, it is a positive answer, positive function. Why? We can take the positivity, like I said before, the denominator is always positive, okay? Because it has 3x squared. It's always positive. Then the only term which is that we have to check is the the numerator, 2x. This is also positive always. Why? Because we consider only when x is greater than equal to 1. Okay, because we consider this is the only part we consider. So when x is greater than equal to 1, this is always positive. So this is a positive one. Okay, so we have to find another condition whether this function is decreasing. So yes, this is. So decreasing, how to find? We have to again find the first derivative. So Alexis said yes. So what is the first derivative now? Here you have to use the quotient rule. I hope you all remember the quotient rule. So what is quotient rule? If I recall again, if you have u over v, this is v squared, v u prime minus u v prime. So this is called the quotient rule. So we need to find what is u is equal to 2x, v is equal to 3x plus 4. So u is 2, u prime is 2, v prime is 6x. So we can find the first derivative by just using. So the first derivative you will get I will quickly write. So v squared is 3x squared plus 4 squared. 3x plus times 2, 2x, 6x. You will get 6. So for the first derivative, you will get something like this. Now we need to check whether this is decreasing or not. Whether this is negative, because if the first derivative is negative, we can say this function is decreasing. So to check the negativity or the positivity, here, like the argument we mentioned, always take this is a square. So it's a positive. Okay, so the only part we need to consider is the denominator. So let's see when will this be a positive one. So let's just set 6x squared plus 8 to 0 and find the x value. So x you will get 2 square root 3 plus or minus square root 3. Okay, now we need to check the sign test. So this is the numerator. So sign test, if it is this, and then if it is less than negative 2 over square root 2, what will happen? So let's just check. So 2 over square root 3 is, it's about 1.155 roughly. So let's take a point here. Let's take a point here. Let's take a point here and just check the sign. Okay. So can you, let's say when x is equal to 2, what is the first derivative? Is it positive or negative? Negative? Yes, it is negative. So because x is 2 means here you will get 4. So you will get a negative value. When x is equal to 0, what is the first derivative? Positive, yes. When x is equal to 0, it is positive. When x is equal to 2, so this is negative, this is positive. Then what happened when x is equal to 2? It's negative. Okay, so the first derivative is negative. Now we have a problem. Okay, because this 2 over square root is 1.155. Okay. We need to check our conditions. X should be between 1 to infinity, right? But here you see, so that interval is this. Okay. So in this interval, we have to check whether the function is decreasing or not. So here f is decreasing, here f is increasing, here f is decreasing. So you see we have both two parts here, increasing, decreasing both. Okay, so we cannot, so f is not decreasing in this whole interval 1 to infinity. Did you understand this part? Any questions? So at this, how did I get these ones? I set the numerator to 0 and then found the x values, and then I did the sign test. So I get f is not decreasing in this part, but and also remember in sequences that is n is what? Is positive or negative integers. In sequences, we mentioned it's very important. N is positive integers, okay? Integer. So when we are considering, because this is what we want to know, whether it's convergent or it's divergent, N is always positive. So when N is equal to 1, F is decrease. If F is not decreasing, but when X is in this interval, that is 2 to infinity, that means 2 is here, somewhere here, then that part is we get decreasing function, right? Because always it is, because here you see when x is equal to 2, we had the first derivative is negative. So it is f is decreasing. So in this part, f is decreasing. So let's find so we cannot use the integral test from 1 to infinity. Instead, we have from 2 to infinity, all these conditions are satisfied. Okay, so let's find the integral from 2 to infinity, because then we can use the integral test for this. Can you all check what is the value for this? B, 2 to B. So we can use integer. Let me explain, Lexi. I'm just using, just take this integral, then I will explain why I'm taking this. Okay. I'm not using integral test here, but I'm just find this integral, then I will explain why I'm using this. So you have to find, let's just find the integral of 2x over 3x squared plus 4 So what is the integral of this one? You can use U substitution. By U substitution, take U is equal to what? 3x squared plus 4. Then du is 6x dx. So your dx is this. So then we can use 2x u. Dx is du over 6x. This get cancelled. 1 over 3 ln u. And u is 3x squared plus 4. I don't take the absolute value because here you see it's always positive because x squared. So you don't have to use the absolute sign. Okay, now let's find from here to here. When limit b approaches to infinity, we found that this is the answer for the integral, that is 1 over 3 ln 3x squared plus 4. Put the limit to be 1 over 3 ln 6b squared plus 4 minus ln 16. Okay, what is the answer for this then? What is the answer for this? Is it, what is the limit of this whole part? So always remember limit of a like limit when the natural log of infinity, not limit, I'm sorry. Natural log of infinity, this is always infinity. Okay. So here we get what? So is it infinity, right, Lee? So it's infinity. When b goes to infinity, this inside this part is infinity. It doesn't matter. This is a number because infinity minus a number, it's infinity. Okay. Okay. So we have, what did we found? We found from 2 to infinity, fx dx this is infinity. Okay, that means this is diverges, right? Because it's infinity. Okay, but we need 1 to infinity. Okay, so if you draw the real line, if 2 to infinity is diverges, this 1 to infinity is anyway diverges, right? Okay, because if this part is diverges, then it doesn't matter you take 1 point outside of 2, this is anyway diverges. So we can say this is also infinity. Therefore, this is diverges. So if it is diverges, we found this integral is diverges, then what can we say about the series? It's also diverges. Okay, so then the series also diverges. Also diverges. Okay, so start. So Lexi, now can you understand why I took 2 to infinity? Yes, Lexi. Okay. So that's why I took, I find 2 to infinity. Okay, so because this one, we found this one is diverges, that integral. So we can say 1 to infinity also diverges. Okay. So okay. Uh, so I didn't get that question. So someone will ask why, because 1 to infinity is infinity, why the series is diverges, that idea. How did I get that idea? I just did some steps in my mind. So what is 2 to infinity dx? This is same as, we can write this as, if C as a series, n is equal to 2 to infinity, right? So this is, because this is diverges, then our series means, so series is 2n 3n squared plus 4. So this is diverges. Okay. And then, but what do we need? We need to find this series. N plus 1 to infinity, 2n, 3n squared plus 4. Okay. How do we get this infinity in terms of this? So this means we are starting from A2, A3, A4, like that. Okay, this means it's A1, A2, A3, like that. But we have this series, this sum, because this sum is same as this. So we can write this is 2n, 3n squared plus 4. What is the first term of this series? What is A1? What is A1? You just substitute when n is equal to 1. So what is A1? 2/7. Yes, 2 over 7. When n is equal to 1, it's just 2 over 7. 2 over 7 plus this whole thing. Okay. We found this is diverges. That means this whole thing was infinity. When you add, this is infinity, it diverges. So whenever you add a number to infinity, this will also give an infinity. So that's why it is diverges. So that's why from n is equal to 1 to 2n, 3n squared plus 4 diverges. Do you understand now why it was diverges? Okay. Okay. So let's do an easy, some kind of easy one. What about this example? Whenever you have this. What is this series? Can you all identify what is this series? I mentioned this in the beginning of the class. What type of series is this? Harmony? Yes, it's harmony. So it's a harmonic series. And we straight away said the harmonic series is diverges. It's like the proof, I said the proof of the harmonic series is diverges is in the book. But now we are going to use this integral test to show that harmonic series is diverges. Okay, so let's use integral test to prove the harmonic series diverges. So this is another proof of harmonic series is diverge. So what is the corresponding function? That is 1 over x. Okay, so we need to check whether this is continuous, whether this is positive, or whether this is decreasing. What do you think? Is it so? Let's draw the graph of the function. So your function will look like this. The graph of 1 over x will look like this. But we consider only when x is equal, this is your x, when x is equal to 1 to infinity. Only this part. Okay, so that means we are going to consider only this part of the graph. That is this part of the graph. Okay. Okay. So now what do you think? Is it continuous? If you consider this part, is it continuous? Yes, right? Because there is no holes or anything, no discontinuity. That is continuous. Okay. Then what about, is it positive in this part of the graph? Yes, it's positive. Okay, because it's always above the x-axis, so it's always positive. Is it decreasing? What do you think? I see Jai says decreasing. Yes, it's decreasing. Lee. Yes, so it is decreasing. Why? Because you see it's from the graph. So that's why if you know the basic graph, so these kind of thing, you know the basic graph. So you can just say by the graph, we can take all these three conditions. Okay, so because these three conditions satisfied, we can use the integral step. So we can use integral test. Okay, so by using the integral test, that means we have to find 1 to infinity 1 over x dx. Okay, so we are going to write this as b approaches to infinity 1 to b 1 over x dx. So this is what is the antiderivative of 1 over x. It's just ln x, right? Natural law. So it's just ln x 1 to b. B goes to infinity ln b minus ln 1. So ln 1, what is the answer for this? What is this one? What do you get the limit of this whole thing? Infinity, yes, m says infinity minus 0. Okay, so yes, I said the natural log of infinity, it's always infinity. So we get infinity minus 0, then infinity. Okay, because this is infinity, that means by the divergence test, we can say this integral diverges. And then what can you say about the series? Because it's diverges, our series, that's also diverges. Good marriage. So it is 1 over n diverges. Okay. So let's do one last example for this, another like a type of question. Example, you have to find whether this series in 6n plus 10 is convergence or diverges. Okay. So let's see how to find the convergence. So first write the corresponding function, that is fx 2 over x squared plus 6x plus 10. But whenever you write this, we cannot see anything, right? We cannot see whether it is positive or negative. We don't know anything about this. So I'm going to change the denominator, because x squared plus 6x plus 10, I can write this as a perfect square of a binomial by, let's say, x squared plus 6x. I can make a perfect square binomial here. How do we do that? So if I divide the middle term by 2, 6 divided by 2 is 3, and then I square it, that is 9. So if I add 9, this whole thing is x plus 3 squared. And because it's 10, I just write 1. So what I did is, I wrote 10 as 9 plus 1, so that I can write a perfect square binomial. I will explain why I'm doing this. So you will get x plus 3 squared plus 1. So this is same as this. Why am I doing this? Because you know already the definite integral of this x squared plus 1. What is the definite integral of this? I said this is very important. You have to remember this. What is the definite integral of this one? Can you remember? tan inverse, right? This is tangent inverse of x. Okay, so you can see it's kind of this is kind of like this. So if we use the substitution, we can use this one. So now let's check whether the function fx. So we have now x plus 3 squared plus 1. Okay, now is this continuous? What do you think? So we need to use the integral test. We need to check whether the conditions are satisfied. So is it continuous? What do you think? I see. Correct. Yeah, I see. It is continuous, right? Because it doesn't have any discontinuity point. Because here we have x plus 3 squared. So it is continuous. Okay, no discontinuity point. Points. Okay. Then what do you think? Is it positive? What do you think? Is it positive? Yes, I see. Jai said yes, yes, yes. So it is positive because here again it's a square. So numerator is positive, denominator is always positive. So it is positive. So we have that. Is it decreasing? What do you think? So you can check the yes. So you can check the decreasing by taking the first derivative. But here this is kind of, if you roughly draw the graph, your graph will look like, so at x is equal to -3, this is the maximum we get. Here you will get 0, 2. So if you draw the graph roughly, you will get something like this. Okay, but we need only this part, that is 1 to infinity. Okay, so like we discussed before, this whole part is decreasing by looking at the graph. So if you can draw the graph, you don't have to find the first derivative. Okay, so by looking at the graph, we can say f is decreasing too. Okay, okay, now you can use the integral test. So can you all use the integral test and tell me? So 1 to infinity, 2 over x plus 3 squared plus 1. So this is same as limit b goes to infinity, 1 to b, 2 x plus 3 squared plus 1. Okay, so what is the answer for this? What is the answer for this? You can use so here we are going to use trig substitutions. Trig substitution I'm going to use, because here you see we know, because I said because we know this kind. I'm going to use x plus 3 is equal to tangent theta. Okay, then dx, when you differentiate right hand side, you will get secant squared d theta. Okay, so then if I just find the integration of this. So I can use, this is tangent square theta plus 1 multiplied by dx is secant square theta d theta. This is secant square theta. So we can cancel this to this. So you will have 2 d theta, that is 2 theta. And we can say this is tangent inverse x plus 3. Okay, so we can write here limit b goes to infinity, tangent inverse to x plus 3. Okay, so from here to here, this is equal tangent inverse, when you substitute 1 to b, tangent inverse b plus 3 tan inverse 4. So what is when b goes to infinity, what happens to tangent inverse? What do you think? What is tangent inverse of the infinity? Pi over 2, yes, very good. So you can use the graph. So tangent inverse, this is the tangent inverse graph. So this is like this. Here, this horizontal axis is pi over 2, negative pi over 2. So when b goes to infinity, that means this whole thing is pi over 2 and 2 and then minus 4. Okay, you see this whole thing is a finite number, right? Finite number. So what can we say about the integral? So by the integral 1 to infinity, 2 over n squared plus 6n plus 10 is converges. Converges because we found a finite value. Then by the integral test, we can say, we can say this whole series is converges. Okay? So we found the whole series inverse. Okay. So what did we learn up to here? So like I said, at the end of the day, we need to find whether the series is convergent or divergent. So today we learned a kind of technique, the integral test, to check whether the series is convergent or divergent. Okay, but to use integral test, we need to satisfy 3 conditions. That's the function is continuous, decreasing, positive, then we can use the integral test. So that's that. Another technique we are going to use EP series. So now we are going to learn a new series. This is called P series. P series. So this is same as the sequences. It's the sequences. Remember we did P test for sequences too. It's the same idea. So here in the P series, when you have to find the infinite series, of 1 over n to the power p. Okay. Then if p is greater than 1, we say the series convergent. Okay, it's that basic idea. So if p is less than or equal to 1, then we say series is divergent. Okay, so can you find what is now this is we know harmonic series is anywhere. So what about this? What is this? Is it divergent or convergent? By using the P series? It's divergent, right? Because this harmonic series, anyway, we know it is divergent. Then yes, this so we prove now this has 3 proofs. First, we can use the partial sum proof and show that it is divergent. And this again, this example we did in the previous one, integral test. So that was also divergent. This is P series. Another one, what about this? 1 over n square. Is it diverges or converges? It's convergent, right? Yes, good. Why? Because P is equal to 2. This is greater than 1. So the series is convergent. Okay. Then what about this? Now can you all think about this? Is it convergent or divergent? This is n to the power negative pi. What do you think? Is it divergent or convergent? Diverges, some say diverges, others it's convergent. Yes, yes. So, yes, William, yes. So it is because now this, we cannot use P series for this. First, we have to change it. So we can write this is equal to 1 over n to the power pi. What is pi? What is the value of pi? Can you remember? It's 3.14, right? It's 3.14. Okay, so that means your p-value is 3.14. This is greater than 1, right? So it is, we can use the p series and then we can say this is convergent. I hope now you understand. Okay. Okay. Now for the last example, what about if you have something like this? N to the power negative 2.8 n to the power negative 1.6. What do you think this? Is it convergent or divergent? So I'm going to write this. I'm going to change it because it's addition here. I'm going to write this in this form. I'm going to write it separately. N to the power negative 2.4 plus, again series and 1 to infinity, 8 to the power negative 1.6. Convergence, yes, I see. And then I'm going to write this in terms of, because we are going to find whether we are going to use P series. So this is negative exponent, I'm going to write it like this. And this I can take 8 out. And 1 over, it's about 1.6. Okay, now this is separately, this is convergent. Convergent. Why? Because P is greater than 1. Here, this also convergent. Why? Because here you see it's P greater than 1. So both two parts are convergent. We can say the whole series is convergent. Okay? Okay. And then I'm going to move on to the next, the last topic of the class. Okay. This is called the, so this is P series. Then the next type is, next type means now it's just a new part. Remainder, we call remainder test for integral test, test. So to understand this, before giving the definition, I will give you a question where we use the remainder test. So the first one is approximate the sum of the infinite series 1 over n squared using sum of the first 10 terms. And then second, this is part A, this is part B. Estimate the error, estimate the error with approximation. Okay, so let's first do the first part. Okay, what is, so approximate the sum of the infinite series. So that let's write it, infinite series 1 over n squared. So just approximate this using sum of the first 10 terms. So that means you just write n is equal to 1 to only 10. Now, not infinity, only 10. That's why it is approximation. Up to 10 values of 1 over n squared. Now, what is this idea? Remember we did yesterday. What do you call this one? This is infinite series. And this, it's a partial, right? We take the partial sum. So that means this is Sn. So that means what is the question asked is, when n is equal to 10, you have to find S10, S sub 10. So what is S sub 10 means? That means you add all the first 10 terms. That is A1, A2, A3, like that, up to A10. Okay, so this I will just write it because we don't have much time. So this is 1.549768. Okay, because they're asking what is the sum of the first 10 terms. So the idea is, so the infinite series of 1 over n squared, this is approximately, we can say it's 1.549768. Just the approximation. Okay. And you see, this is a finite number. Anyway, by P series, we know this should be convergent. This partial sum for 10 terms, it's also a number, so it's convergent. Okay, now let's see how to find this, estimate the error approximation. So that's where we are going to use this one, remainder test. So let's first write remainder estimate 1. What is this idea? Remainder estimate for integral test. So this means, so in the beginning of the class, we said that the n term of a sequence, we can write like, let a function, right? F at n. Okay, because sequence is, a number is always a function at 10. Now, to use this remainder estimate, you have to show that f is positive, like the integral test, positive, and it is decreasing, and this is continuous. I hope you know. So continuous, I just write it like CTS, continuous. And this in the integral test, we took x is greater than 1. But in the remainder estimate thing, the difference is we check these conditions, whether these conditions are true when x is greater than or equal to n. Okay. Okay. And also there's another condition, and the series A n is convergent. So we have to check this part, and whether we have to check this series is convergent. And then if the remainder, we write it as capital R, this is called a remainder. This is equal to S minus Sn. Let's sub n. This means it is the, like the sum of the infinite series, and this is the partial sum. Then we can say this remainder Rn is between these two integral when it is n to infinity of fx dx, and here n plus 1 to infinity of dx. This is called the remainder estimate. Okay, because in this question, they are asking you to find the error. So what you have to do is, you have to find Rn and say that the error is between these two numbers. That's what we are going to say. Okay. Okay, so to do this, so n we far, it is in the question says n is equal to 10. So we have to find R10. Okay, but to use the estimate, to use this one, we have to satisfy all these criteria. Okay, so can you all check whether the corresponding fx is 1 over x squared? So is it positive? What do you think? Is it positive? Don't worry, this is the last question of the day. So yes, it is positive because of the denominator, it's x squared, it's positive. Okay, and then is it continuous? What do you think? Is it continuous? It's continuous. Why? Because here we only consider when x is greater than 10. If we draw the graph, your 1 over x squared will be look like this. Okay, but we only consider when x is greater than 10. So that means we consider only this part of the graph. How did I get this 10? Because in the beginning of it says when the total number is n is equal to 10. That's why it's 10. Okay, so it's continuous. Is it decreasing? What do you think? By looking at the graph? Yes, by looking at the graph, it is decreasing. Okay, so we have these three conditions, and then we can find what is the series of a sub n, that is a sub n is 1 over n squared. So we have to check whether it is convergent or divergent. Is it convergent? The first part we have proved. The second part we need to show that this is convergent. Then only we can proceed. So what do you think? Is it convergent or divergent? Yes, right? It is convergent. Convergent. Why? Because of P series. Good, very good, Kyla. So this is P series by P series. Okay, so we have these conditions also. These conditions also. Okay, then we can say, then if R is equal to S minus S and Rn. So this is, as I mentioned, R is the remainder. If this is true, then we can say, now we can use, because all these conditions we satisfied, and this is true because remember, because this one was an approximation we took, 1.5 something. It's an approximation up to 10, but definitely in infinity of this one, it should be greater than this one. So this is also true. So then we can use the error. This is error should be between, this is your equation. So n is 10 to infinity fx dx. Now this is 11 to infinity fx dx. So let's just use just find one of it. So can you all find what is fx is 1 over x squared? What is the definite integral of this? Sorry, it's yes, x squared. What is the definite integral of this? Yes, negative 1 over x. So definite integral of this is negative 1 over x. So let's just find for one value. let's say just maybe like 10. Let's use just n, because then we can use. So let's use n here. 1 over x squared dx. We can write limit b goes to infinity n to b 1 over x squared dx. Limit b goes to infinity. This is 1 over b minus plus 1. I'm sorry, it should be not 1. It should be 1 over n, because it's n here. 1 over n. But when b goes to infinity, this whole thing goes to 0. So you will end up of getting 1 over n. So if the infinity from n to infinity, it's 1 over n. So we can now substitute for here. So when you substitute for here, you will get your error term. So error term is the remainder. It is between 1 over n and between 1 over n plus 1, because it's the same thing. Same procedure we are going to use to find the bounds when n plus 1 to infinity. So this means because n is equal to 10, 11, and error is 1 over 10. So error is between these two numbers. That is, remainder is between, this should be 0.9090. So the remainder estimate is between these two values. Okay, that's why we learn. So we learn remainder estimate because to find like errors, if to find the error, that means error means what do you mean by error? Error means, so what is the infinite series value? And then we are taking the partial sum. Then what is between the remainder? Between what is the error? So we said approximately, if we take this from 1 to 10 terms, we said it is 1.59 something. But what is if the series goes to infinity, you get another value, then what is the difference? That's called the error. Okay, so that's to find the remainder. To find the error only, we use this remainder estimate part. That's why we learned this. Okay. Okay, so that's all for today. I'm not going to do more. So on Monday, we'll do more other type of series. Like we have other techniques to solve the convergent or divergent. So your second test, it will look, so I have an idea how I will give test 2. So test 2 will be like, I will give you some series. You have to check and sequence, and you have to say whether it is convergent or divergent. Convergent or divergent, like that. Okay, so test 2 will be like that. Okay, that's all for today. So see you on Monday. When is quiz 5? I didn't put the date, but you can submit before Monday. Okay, so Monday. Submit the corrections. So the corrections will be until Monday. Before Monday, just send me So you have the weekend to do the work. So you can submit the correction before Monday. Just send me an email. Okay. See you. Good. Have a good weekend then. Bye.